So the first thing that you notice is this is a continuous function because sine is continuous, cosine is continuous. So you just have a sum of two continuous functions and you have a closed interval. So this is a continuous function on a closed interval. And so that means that we are going to compare our function values, f of x values, at two places, the critical numbers and then at the endpoints. Okay? All right, so to start, we need to take our derivative to find the critical numbers. So the derivative of sine is going to be cosine x. Derivative of cosine is negative sine x. Now, for our critical numbers, we need to set the derivative equal to 0. We could think about where the derivative does not exist, but that really isn't going to come about for anything because there's no denominator. This is perfectly well defined for all real numbers. So it's just going to be about where the derivative equals 0. Now, we have a trig equation. The big thing to notice is that cosine is first power, sine is first power. So because you have what we call a linear trig equation, what you will want to do is isolate a trig function. And it honestly doesn't matter which one you isolate. So I can get cosine by itself or I can choose to get sine by itself. So in this case, I might say, okay, let me get cosine on the left-hand side. So I'd add sine x to both sides. And that would give us cosine x is equal to sine x. Okay? Now, once you have your trig function isolated, you then want to look at your unit circle and try to figure out on the unit circle what information you can get to solve this equation. So the cosine x equals sine means that we want our x coordinate on the unit circle to be equal to our y coordinate on the unit circle. So to answer that question, we're going to have to go to our unit circle. And if you think about where the x and y coordinates are equal, that is at the pi over 4 angle. Now, it's certainly true that at pi over 4 they are equal, but if you think about in quadrant 3, x is negative and y is equal to a negative as well. So you have pi over 4, 3 pi over 4, 5 pi over 4 that will also be an angle for which cosine is equal to sine. So your two answers here for your x, because remember you're trying to solve for x, is going to be that x can be equal to either pi over 4 or 5 pi over 4. Now, you could think about adding like in pi and all of that, but the reality of the matter is we are not going to do that for this question, because for this question, we're just interested in from 0 to 2 pi. So from 0 to 2 pi, pi over 4, and 5 pi over 4 are the only two angles in that interval. Okay, so once you have your critical numbers and you have your endpoints, we are going to go over here and think about the function values at those points. So our function f of x was equal to sine x plus cosine x. So we'll start by plugging in 0, and this is where we're really going to have to know our unit circle. So if you think about your unit circle at 0, your coordinate is 1, 0. So your sine is 0, your cosine is 1. So f of 0 is going to equal 1. Okay? Then you look at your next point, pi over 4. So here your sine of pi over 4 plus cosine of pi over 4. So sine of pi over 4 is square root of 2 over 2 plus square root of 2 over 2. Now, do not overthink this, you guys. If you had x plus x, you would say that it's 2x. The same thing is happening here. You have 1 square root of 2 over 2 plus another square root of 2 over 2. So that is going to give you 2 square root of 2 over 2. And then, of course, these 2's cancel out. So you get that f of pi over 4 is simply square root of 2. Okay, so that's our other function value. Then we had to look at f of 5 pi over 4. So we plug in sine of 5 pi over 4 plus cosine of 5 pi over 4. Okay, so our sine of 5 pi over 4 is square root of 2 over 2 plus cosine of 5 over 4 is also negative square root of 2 over 2. Okay, so the same thing that happened up here with the pi over 4, you have a negative 1, so that gives you negative 2 square root of 2 over 2. So that tells us that f of 5 pi over 4 is negative square root of 2. Okay, just one more to go and then we'll be done, okay? So our f of 2 pi, again, this one you might notice is the same thing as f of 0 because that's the same coordinate, so you don't really have to do any work there. You can just say f of 2 pi, same as f of 0, which is going to be 1, okay? All right, so we compare all of these values. Keep in mind square root of 2 is going to be greater than 1. So the highest value is going to be the square root of 2. That's our absolute max. And then the lowest value will be the negative square root of 2. That will be our absolute min. Okay? All right, so we would say the absolute max is square root of 2 at x is equal to pi over 4. And then the absolute min is negative square root of 2 at x is equal to 5 pi over 4.